Okay, so remember when we looked at the graphs and the charts and we were able to see how things were changing? Remember the cost of something, like a ticket went up $10 each time. That's a constant rate of change. I don't think this is news to you guys. You know about this, right? So you know that every time you buy milk from the cafeteria, it's how many cents?
3.
Anyone know? 50 cents. Say it's 50 cents.
It's
Every time you go, it's 50 cents. That's a constant. Okay? So let's look at this. Constant means a linear. It means linear when we're talking about rate of change. Remember how we talked about straight line through the origin? Linear is a straight line. So if linear is a straight line, what is a constant on a graph? What would it look like? Squiggly line? Crooked line? Straight line. Good. So constant is going to be a straight line. That's the linear part of the definition. Okay? So we use tables, charts, and graphs to solve these. That's primarily what we'll look at in junior high and high school math. They will give you a chart, a graph, a table, and they will say, is this a constant rate of change? Is this linear? And then you have to be able to read the chart, the table, and the graph and decide for yourself, is that constant? The graph's pretty easy to read, right? If you see a straight line, you know it's constant. But if it's a table or chart, you have to do a little bit of work to figure that out. Okay? We can also use an equation like the one that we just figured out with the proportions, remember? This times that equals that times that, and then remember we divided. So we use equations to find the constant. So basically Math 7 introduces you to this concept, and then in Math 8 you spend 2 months on this concept. So I'm not going to spend the 2 months on the concept, but I will introduce you to it. The equation looks like this. This is important. That's why there's a box around it. Y equals kx. Okay, so y equals kx. Now this is weird. This k and this y. Well, we've seen x's and y's in graphs, right? But we haven't seen k's. Anybody have an idea what the k would stand for? What do you think it stands for?
Same thing as x.
Not the same thing as an x. It's in front of the x. What do you think?
A constant?
Yeah, it actually stands for constant, but it's a k instead of a c. Isn't that weird?
I can see it.
Oh. So, why do you think that the k stands for constant? Did math start off in English?
No.
No. Right? So there's actually some Greek or Latin or something like that. I think it's Greek. Anyway, so don't be confused by the letter so much. Just know that k equals constant. K is the rate of change. If the tickets are $10 each, K is the $10. That equation you will see over and over and over again until you finish college. And if you're like me, you'll see it your whole life. But if you don't teach math, you might not. But that equation is like the foundation for all of your next few years. Okay? Also, if you do calculus, you'll use it again. Okay? So it's super important. So just to illustrate it, we're going to look in our book, because if we had to write all this stuff down, you would go crazy. So there's a couple actually I wrote down 5 there. So we're going to look at the book. I'm going to keep recording because that's really part of the notes still. So you guys turn in your book to page 69, 1 through 5. Okay, and now that you're on that page, can you guys notice that there's charts and graphs and stuff? And I didn't think you wanted to rewrite these in your notes, right? Okay, so your book is still the extension of your notes. Okay, so we're going to look at this page real quick and do some of these problems together. And then I'm going to have you do some on your own later. Okay, so let's look at number 1. This is page 69. Find the constant rate of change for each table. All right, so let's start on the left side. How are these changing on the left? All of these? What are they doing? +1. So write +1 and put your little arrows there. You did this in 6th grade, I believe. Now on the right, how are they changing? +6. Does everybody agree?
Yes.
Okay, so to figure out our constant or our rate of change, we go back to our unit rate. Remember our unit rate thing? Has to be over 1. So raise your hand if you think you know what the constant is here. What do you think, Austin?
6 miles or meters per
Yeah, they're meters. Good. So it's actually 6 meters per 1 second. Because we have S and M. Those are the meters per second, right? So it's just basically taking 6 over 1. Do you guys see that? 6 over 1. Now, the interesting thing about charts is, remember when you did those charts where you had to like plug them into a graph? Do you remember what they were, like input, output? Remember those? Do you remember, was this X or was this Y? The first one. X. Good. So you remember that? And then Y? Do you guys remember when you had to plug stuff in? X and Y, or input, output? So the interesting thing here is you notice in our answer that Y is over X. Do you guys notice that? And it will always be that way. It will always be this side over that side. And so I can write a little note here to remind you that it's always Y over X. So make sure you write X and Y up there. And then something like with Y over X to remind you on the side. Okay? That's super duper important. That's going to carry you through 8th grade math for sure if you remember that. That Y is always over X. I'll explain why later, but let's just remember it for now. Okay, let's look at the second one. How is the left side changing?
+2.
Good. Everyone agrees?
Yes.
Each time, right? How is the right side changing?
+18.
+18. We want to make this a unit rate, so let's put 18 over 2. Or, yep, 18 over 2. That's our change here. 18 over 2. What's that, you guys?
$18 over 2.
But we wanted a unit rate, so what do we put? $9 per 1 item, because we don't know what it is. Okay? Again, X and Y, and that's Y over X. So we always go back to the unit rate. Any questions so far? It's pretty easy. Okay? Just a fraction, then simplify. Let's look at number 3 because now we have a graph. It's not a chart. It's a little different. We have a straight line, right? You guys see the straight line? And then there's like these other dotted lines. Do you see all those? And these points. Does that look confusing to you?
No.
So these points are coordinates, right? And so if we go over 1 and up 9, that represents that point, and so on. And these look like little stairs, right? So it says the graph shows the cost of purchasing t-shirts. Find the constant rate for the graph, then explain what the points mean. So first of all, can someone figure out the constant rate here?
+9.
How'd you get 9?
Because 9 times 2 equals 18.
Oh, so you're saying it's going up 9 each time here? Do you guys see that?
Yes.
9, 18, 27, it's going up 1 here. So we could say the constant is $9 per shirt, right? So write that down. And now we have to identify what, or explain what 0, 0, and 1, 9 mean. So who can explain what 0, 0 means in this particular chart? You can? What do you think it means?
It means like the start where there's nothing.
Start where there's nothing. A little more detail. Anybody? Darian? Okay, any more detail? We know it's called the origin. Zach?
The beginning of the
That's kind of said, the beginning. Anybody else? More details? Yeah? Jarek? That's been said. Anything else? Like, what do those numbers even mean? Nicholas?
Where X and Y meet.
Kind of said all that. What do they mean, though? What do the zeros mean in this particular situation? Yeah? Lindsay?
It means they started at 0 shirts.
0 shirts cost how much money?
$0.
Good. So 0, 0, write this down, means 0 shirts cost $0. So for so many years, you guys have been given these charts and graphs, and they mean nothing to you, right? Nothing to you. They're just like charts and graphs on a piece of paper. And then your teacher's like, find a constant, or find this, or whatever. But you have to make meaning of it, otherwise it will never stick with you. It will never stick with you if you're just like memorizing stuff, right? We have to know why. So now we know 0, 0. What does 1, 9 mean? Anybody? Yeah, Taylor?
1 shirt is $9.
Wow, that is awesome. 1 shirt, you're exactly right, costs $9. Hopefully that makes more sense to you, right, than just looking at a graph. Okay, I kind of want to analyze this graph a little bit more because there's these red and blue dots. Was anybody else thinking about that? Not really, because you don't teach math? Okay, so here's the X. Everyone circle your X. Everyone circle your Y. Remember up here we said Y over X, right? So, like, let's just look at the top one. If I did Y over X, which one is Y? 3 or 27?
27.
Good, because remember it's always X comma Y. So 27 over 3 is what? 9, which is what we said, right? So do you guys notice these little things right here? So this is going up 9. It's going up 9. And how many is it going over?
2.
Well, technically look at down here at the bottom numbers.
1.
Okay, good. This one's going up another 9. How many is it going over?
1.
This one's going up 9. How many is it going over? So that is another way to find our constant, isn't it? We could just count the squares. Did you guys notice that? So it's going up 9, so like plus 9, plus 1 each time. That is the Y over the X, isn't it? Y over X. Do you see it? Y over X. I'm going to do a ton of that next year. Lucky you. All right, number 4, the Guzmans and the Hashimoto's. They're taking a 4-hour road trip. The distances traveled by each family are shown in the table in the graph below. Which family averaged fewer miles per hour? So let's look at the Guzmans first. So how is the left side changing? By 1. How is the right side changing? You have calculators, see?
By 90.
By 45, thank you, each time. Okay, so this is miles and this is hours. So how many miles per hour are they going? 45. Good. Okay, so let's write that. 45 mph so we know. We don't forget. Again, Y over X, right? Now let's look at the Hashimoto's. So it says miles here, so these must be hours. They didn't write it, but we'll write it. So I see a dot here. So that's 2 hours, and they're going 120 miles. And then at 3 hours, they went 180. So how is this changing right here? 60. Everyone agrees it's constant there? Okay, and then down here it's changing by what? 1. So what do you think this one is then? How fast are they going?
60 miles per hour.
Good. Do you guys understand that? Good. So which family averaged fewer miles per hour? Guzmans. Good. The Guzmans. And then it said explain, and so I would just say because, BC, they traveled 45 miles per hour. the Hashimoto's, right? I'll just put the H's. 60. Yeah, totally. Okay? So that's an example where you're given a table and a graph and you have to analyze two things to come up with your answer. Do you think you could handle that?
Yes.
I think you could. You're pretty smart. Let's look at the last one. At 1 o'clock, the water level in a pool is 13 inches. Circle the 1 o'clock and circle the 13. At 1:30, circle the 1:30, the water level is 18 inches, circle the 18. And then at 2:30, circle that, it's at 28. What is the constant rate of change? Well, let's first analyze our time. How's our time changing? 30 minutes. Everyone agrees? Okay, so let's say that time changes, just to write ourselves a note, 30 minutes, right? What is our water level changing by? 5. Wait, this one goes from 13 to 8, or 18, that's 5.
Yeah, but the other one's now late.
Oh, good catch. So this one changed from 1:30 to 2:30, right? But if we want to get down to the unit rate, we could put it down to 30 minutes. And this one's going up by 5, but then it goes up by 10, so we still know it's 5, right? So it changes. Is it going up? Yes, right? So changes, put an arrow up, or you can put plus 5 every what? Every 30 minutes. Can we make that a unit rate?
Yeah. It's like 1 every 6 minutes,
Let's make it every hour because that'd be easy to put it over 1 hour.
10 every hour.
Yeah, so let's just put 10 inches per 1 hour. Or how many per minute?
You can have 1 per minute.
5 inches every 30 minutes. 5 every 30.
6 inches every minute.
Close. That'd be too many. 5 and 30 would be what? What's 5 over 30, guys? No. 5 over 30 is what? 1/6. Good. 1/6 every minute. But in this case, we'll just put it over 1, so we get it 10 over 1 hour. Okay.